is how to find the empirical formula when I give you percents. So this is the steps. The key to this test is going to be knowing when to do what steps. Okay, at the very last day of this unit, I'm going to give you a breakdown of all the different types of problems we're going over, and you've got to be able to do them. So empirical, the way to remember the steps is simply remembering this little rhyme. So percent to mass, mass to mole, divide by small, multiply to whole. So step 1, percent to mass. Step 2, mass to mole. Step 3, divide by small. Step 4, multiply to a whole. Now you may want to pause the video for 1 minute to allow everybody to get out at least 4 different color markers, pens, whatever for this. Each step you need to do as a different color so you're able to visualize what's happening. Okay. Example 1. A compound is found to be 34.53% zinc, 14.79% nitrogen, 50.68% oxygen. Calculate the empirical formula for this compound. Now this is somewhat what forensic scientists do. They find a bunch of different elements or chemicals laying around a crime scene, and they're responsible for figuring out what that substance is. So they do analysis of what chemicals are there. Then they take these percents and figure out what compound, what actual substance was at the crime scene, and then they go from there. Okay, so this is what those forensic scientists do on TV and whatever else, and in real life. So at the crime scene, they found 34.53% zinc, and then so forth. So step 1, okay, step 1, percent to mass. This just means, literally, you're going to change the percent signs to G's. Because if you have 34%, 14, and 50%, they all equal 100 because they're percents. So I'm going to assume that we have 100 grams of whatever this is. So if I assume we have 100 grams, then that means you have 34.53 grams of zinc and so forth. So step 1, literally, just change the percents to G's. Okay, switch colors. Step 2 means mass to mole. How do we go from mass to moles? What have we been doing for the past however many days to go from mass to moles? We have been converting. This means you're going to take all 3 of these values and convert mass to moles. So 34.53 grams of zinc, we're going to convert it. 14, not 17, 14.79 grams of nitrogen, and we have 50.68 grams of oxygen. And we're going to convert from mass to moles. So this is why it's important that you've got to be able to do this. It's one of the essentials for this unit and so forth from here. So let's do zinc. We have grams of zinc here. We need to get rid of that to convert to moles. So grams of zinc is here. We're going to put it down below. We're going from mass to moles. So we're going to put moles of zinc on top. With moles, we put 1. With grams, what do I need with grams there? We need the atomic mass of zinc. So look on the periodic table, find zinc, and you should see that it is 65.4 grams of zinc. Grams of zinc cancels. Multiply the top, divide by the bottom. And you should get 0.528. Now we're not doing sig figs here. You can go as far as you want at this point because you're not going to get a numerical value for your final answer. So go as many decimal places as you want. Then you just do the same thing for all the rest of the substances. So grams of nitrogen, so we put grams of nitrogen on the bottom. Moles of nitrogen on top. Moles, we put 1. With grams of nitrogen, you're going to put 14. Now, one of the most common mistakes, and I know I've embedded this into your head, is nitrogen is a diatomic. Yes, but this does not matter because nitrogen is not by itself. Nitrogen is in a compound with zinc and oxygen. So do not put N2. Okay, it's a part of a compound, so it's not a diatomic. So therefore, you put 14 here, 1 mole there, grams cancel, multiply the top, divide by the bottom. So 14.79 divided by 14. You get 1.056. Same thing with oxygen. Grams of O, moles of O. 1 mole is 16 grams. Grams cancel. Multiply the top, divide by the bottom. 3.168. That is step 2. Okay, so go back, reflect on what you just did. Step 1, we went from percent to mass. Literally just changed the signs. Step 2, mass to moles. These are all mole amounts. Okay. Step 3, divide by small. So we have 3 values as of right now. So what do you think it means to divide by small when looking at these 3 values? You're going to take the smallest of those values and divide every single one of them by that value. So in this case, our smallest value is 0.528. So you're going to divide all of the values that you got by that number. So this one obviously is 1. Two. 6. Okay, that's step 3, divide by small. Now step 4, multiply till whole. This means the values that you got are not whole numbers. You're going to have to multiply them all by something in order to get them to be whole. In this case, step 4, we don't need to worry about because they're all whole numbers. Yes, they had some decimals, but they were like 0.0 or 0.9. So that didn't make a difference. Okay, 0.0, 0.9 doesn't matter. So these are the numbers we need. Now, the most common mistake is for students to box that in as their answer. But the question is asking for an empirical formula, a chemical formula. So the thing you've got to know is that once you do all this work, your final answer is to take these values and make them into subscripts. So your final answer is going to be zinc with a subscript of 1, but we don't put that. N with a subscript of 2, and then O with a subscript of 6. So your final answer is Zn into O6. Let's try another one. Okay, at this point, you should be able to get through steps 1 through 3. Now, this one does include step 4, so just continue on with me. You can go quicker than me, whatever you want to do. Just stop at the end of step 3 and then pay attention back with me. So, step 1, percent to mass. This means we just cross these out and turn them into G's. Step 2, mass to moles. So we're going to take 25.9 grams of N and convert. And we're going to take 74.1 grams of O and convert. So grams of nitrogen on top, grams of nitrogen on the bottom. mole of N on top. 1 mole is 14 grams. You calculate, so 25.9 divided by 14, 1.85. Same thing down here, grams goes to the bottom. 16 grams is 1 mole of oxygen. 74.1 divided by 16. 4.631. Okay, now you've got to make sure you're doing every single step, because if you forget a step, your answer is going to be completely wrong. You have to do all the steps. So step 1, change the grams. Step 2, grams to moles. Step 3, divide by small. So out of these two values, which one is the smallest? 1.85. So 1.85 obviously is going to be 1. Now 1.85 here. 4.631 divided by 1.85 gives you 2.5. Do not round that to 3. If you round it to 3, you're going to get the wrong answer. Okay, if you have a 0.5, you need to get rid of it, meaning you have to multiply it until it's whole. Okay, step 4, multiply till whole. So what can we multiply 0.5 by to make it a whole number? 0.5 means 1/2. So to multiply 1/2 by something to make it whole, we simply multiply it by 2. So if your numbers end with 0.5, you need to multiply it by 2. So 2.5 times 2 equals 5. Now, you cannot multiply just this number by 2. Because what these numbers are saying, the 1 and the 2.5, is saying for every 1 N, you have 2.5 oxygen. So for every 1 N, you have 2.5 oxygen. That's the ratio between the two. So if you multiply this one by 2, you also have to multiply the top one by 2. So if you end up with a 0.5 as one of your answers from step 3, multiply everything by 2. This means we're left with 2 and 5, so your final answer is N2O5. Done. Okay. I want you to pause the video and try this one on your own. Check your work and make sure you understand what's happening. If you have any questions about this specific problem, please write them to the side of these notes and bring them to class the next day.